Good morning. Thank you for your attendance to this special seminar. So today we have a talk by Ms. Rayna Hata, and the topic is on motivating robotic exercise body, motivating older adults to exercise through social and personalized coaching. And then, so today, this seminar is co-hosted by our team, Cognitive Behavior Assistive Technology team, RIKEN-AIP, and Special Interests Group on Nursing Care Robot, also Robotics Society of Japan. And thank you very much for your attendance. And thank you very much for your talk. So please start.
Hello, everyone. My name is Rayna Hata, and I am a PhD student at the Robotics Institute at Carnegie Mellon University. My research interests lie mainly in human-robot interaction and assistive technology. I am advised by Professor Aaron Steinfeld of the Transportation Bots and Disability Lab, and I'm currently in Japan as an intern at the National Museum of Emerging Science and Innovation, also known as the MiraiCon, conducting research with the AI Suitcase, which is a navigation robot for those with blindness or low vision. I'm excited to be here today and give a talk about the research that I'm currently doing at CMU, as well as give a snapshot of some of the research that I'm also doing at the MiraiCon. I am super excited to be here, and thank you so much for the invitation. And the title of my talk is Robotic Exercise Buddy, Motivating Older Adults to Exercise Through Social and Personalized Coaching. The work being done here at CMU is supported by the NSF AI Caring Institute. Before we get into the meat of the presentation, I would like to give an overview of today's talk. First, I will briefly talk about what the AI Caring Institute is, and then next talk about some of the related and collaborative projects within the Institute. And then I will talk about the research that I have been doing for the AI Caring, and then finally, I will finish up with a brief introduction to the research that I have been doing at the MiraiCon over the summer. AI Caring is an acronym for AI Institute for Collaborative Assistance and Responsive Interaction for Network Groups. This institute was launched in August of 2021 and is a 5-year initiative funded by the National Science Foundation. We are currently on year 4, and I was fortunate enough to join this grant in the 3rd year in 2023. The grant involves a multitude of universities: Georgia Institute of Technology, CMU, Oregon State University, University of Massachusetts Lowell, Stanford, Oregon Health and Sciences, UT San Antonio, and Northeastern University. AI Caring's mission is to develop the next generation of personalized, collaborative AI systems that improve the quality of life and independence of aging adults at home. We research how we can leverage AI in different settings to benefit various stakeholders of care recipients, caregivers, and healthcare professionals. In order to do this, we split our research into different arenas, which are in the yellow circles in the diagram. Each of the arenas have a different stakeholder and application in mind. Across different arenas, there are not only university collaborations, but also cross-institutional collaborations between the universities that I just mentioned. This year, many of us are starting long-term user studies in assisted living facilities to make sure our work is useful and effective in real-life settings. My project is part of the exercise and physical wellness arena, and we mainly focus on how we can use human-robot interaction to promote physical wellness and motivate older adults to exercise. In the next couple of slides, I will highlight some of the research being done within this arena. The 4 projects that I would like to talk today are the AI-driven social conversation to mitigate cognitive decline, which is being conducted at Georgia Tech; Hi Frida, which is done by a group at CMU; robot-mediated exercise in a skilled nursing facility done by a group at Oregon State; and finally, my project, Robotic Exercise Coach. My project and part of the project for the robot-mediated exercise in a skilled nursing facility at Oregon State is actually part of a collaborative project between the 2 of the universities. So we share some of the information that we have learned from each of our studies to each other. So AI-driven social conversation to mitigate cognitive decline done under Sonia Chernova at Georgia Tech focuses on leveraging AI-driven conversational agents based on OHSU's iConnect conversational style to expand the impact of social conversation for isolated older adults. The 2 research questions that are being explored in this project are: What conversational characteristics do older adults prefer, and what prompting strategies mitigate LLM tendencies to dominate the conversation, interruptions, and disengagement? In their pilot studies with university students, they found a few key issues. The AI would often interrupt users mid-sentence and couldn't be interrupted once it started talking for a while, and there was a noticeable lag between what the user said and how quickly the AI system responded. Since then, they've made a number of technical improvements. They've switched to OpenAI's audio API, which takes in audio directly and streams the response as it's being generated. That means you no longer have to wait for the full response before hearing anything. They've also added a feature so that the AI can now be interrupted anytime the user wants to talk. Right now, they are actively recruiting participants for the next phase of study. And if you're interested or have any questions about the work itself, please contact Abi, who is the student on this project. Next project, PyFrida, introduces a novel framework, Advanced Frida with Shapeshift, that allows for text-guided arrangement of rigid shapes into physically valid and semantically meaningful configurations. This project is being done under the supervision of Professor Jean Oh at CMU. One of the key innovations here is the context-aware collision resolution, which helps the system smoothly converge towards arrangements that are physically plausible. In human studies, participants were significantly better at identifying intended concepts compared to baseline methods. Looking ahead, they are planning field trials to explore how this technology can be used in therapeutic and recreational settings. These trials will focus on how interpersonal synchrony, explainability, and personalization can support exercise and wellness. And if you're interested in learning more about this project, please contact Peter, who is a student at CMU on this project. And then lastly, this project, Robot-Mediated Exercise in a Skilled Nursing Facility, focuses on using a custom robot to conduct a within subjects in-person study at a local skilled nursing facility, and it's being done under Naomi Fitter at Oregon State University. The motivation behind this work is to better understand what older adults prefer during a robot-mediated exercise interaction. Specifically, what makes the experience engaging, comfortable, and effective. They gather both behavioral data and self-reported feedback from participants after each session. To explore this, so far, they have completed a pilot study using the robot to guide functional maintenance exercises. The preliminary results are encouraging as most participants responded positively to the robot and remained active throughout the full session. For their next steps, they're expanding the study and recruiting at Oregon Veterans Home. And for questions about the project, please contact Antara, who is the student at Oregon State on this project. Another project out of this group, related project, is their social robot design for older adults. The robot used in the project in the previous slide is part of this project, and this project focused on the development of open source humanoid robot designed specifically for in situ research with older adults. Their design was created in close collaboration with both older adults and their caregivers, ensuring that the robot meets real-world needs and priorities. The goal is to create a flexible, research-ready platform that can support both therapeutic and social applications with older adults. Some of the key design criteria include support for physical therapy movements so that the robot can guide and mirror exercises, animation design tools that don't require coding, making it accessible for non-technical users, expressive communication to support natural and engaging interaction, a customizable appearance allowing for personalization or cultural tailoring, and finally, robust operations so it can reliably function in real-world environments like homes or care facilities where they are testing. And now I would like to present the project that I have been currently working on. This project began as a collaboration between Roshni Kaushik, who recently just graduated from CMU, and her advisor, Reed Simmons. It focuses on designing a robotic system that can help motivate older adults to exercise regularly. The motivation behind this work is that physical activity is known to promote both physical and mental wellness in aging populations. A study showed that regular exercise can significantly improve quality of life in older adults who live independently in the community. In assisted living settings, it was found that older adults who took part in regular wellness programs had a reduced risk of falling and were better protected against functional decline over time. However, Maintaining motivation and sticking to an exercise routine becomes harder as people age. There are common barriers that include low motivation, lack of social support, and physical discomfort. On top of that, there is a growing challenge in the healthcare system itself. The number of physical therapists in the US is not keeping pace with the rising demand. And therefore, we approach this problem by studying if we can introduce a robotic exercise system to help supplement the increased need of physical therapists and exercise coaches. Roshni, in her prior work, developed a personalized adaptive exercise coaching experience that responds to the user's performance and signs of fatigue. Over time, the system would learn and adapt to the user's preferred coaching style based on various contextual cues gathered during exercise. I joined the project in 2023 and began exploring how individual motivation levels influence a person's engagement with the robot during physical activity. We conducted a user study in the summer of 2024, which I will refer today as Study 1, which helped motivate my current work, referred to as Study 2 today, investigating whether older adults prefer exercising with a social companion or more with a structured exercise coach. To test this theory, we are now conducting longitudinal user studies in assisted living facilities to evaluate the system's effectiveness and user satisfaction in these kind of settings. So first, I would like to dive into the robotic coach system, which Roshni developed. The system was created on the basis that people have different preferences when it comes to feedback styles during exercise. Therefore, context-aware adaptation of feedback leads to improved performance and user satisfaction. We explored two different feedback styles, a firm and encouraging one, and each of the styles, the person was given a combination of verbal and nonverbal feedback. The nonverbal feedback included a range of facial expressions, gestures, and poses done by the robot. The diagram shows a contextual bandit model we use to adapt the robot's feedback system during the exercise session. The robot takes in the fatigue level as the context, and based on that, it selects the most appropriate feedback style to use in real time. This chart shows examples of different feedback styles participants experience when receiving form corrections from the robot. In this scenario, the participant is being corrected on their exercise range. In the neutral style, the robot provides no reactions and no feedback. In the firm style, the feedback is direct and to the point with minimal extra language, exaggerated frown, and slightly more upright position. In contrast, in the encouraging style, it starts with positive reinforcement before delivering the correction. The robot also uses a less pronounced frown and a greater body language. Up until last year and through Study 1, we used the Corey robot for our studies. Corey is not a commercially available robot as of right now, but rather was designed by researchers for researchers as a flexible platform for human-robot interaction studies. The robot features articulated arms and movable waist, which allow it to perform gestures, enabling it to gestures during the interaction. It's also equipped with a camera and microphone, which allows it to capture both video and audio and watch the person while they are exercising. One unique feature is its projected face, which we use to display dynamic facial expressions and provide nonverbal feedback to participants during the exercise sessions. However, just changing how the robot gives feedback might not be enough, especially if someone is not motivated to exercise in the first place. So I started looking at how we can measure motivation levels through conversation before an exercise session, and if those with higher motivation levels tended to engage with the robot more. This part of the project is based off of self-determination theory, which suggests that the more self-determined someone is, the more likely they are to be intrinsically motivated and stick with the behavior. In the long term, I'm interested to see how we can create positive experiences that encourage people to keep exercising and increase their intrinsic motivation. To get a sense of each participant's motivation level, the robot asked a few short questions before each exercise session in the user studies. I used the locus of causality for exercise scale, LCES, and turned them into more of a conversation type question in order to make it feel more natural. The original one, the LCES, is a Likert style scale, so it asked people to answer things in a range of 1 to 7. However, because we were having the participants have conversation with the robot, we changed them into the following questions. The first question in our conversation was asked about the participant's energy level for the day. Our thinking was that if someone had low energy, they might also feel less positive and motivated about exercising. The second question asked whether exercise was something they chose to do on a daily basis. This ties into the first two items on the LCES, which focus on whether the person enjoys exercise and sees it as a personal choice rather than a chore. And finally, we asked if they felt like someone else, such as a family member or a doctor, was making them exercise. This relates to the last LCES item, which explores whether motivation feels internal or more like external pressure. In the summer of 2024, we ran a study with 8 older adult participants, all aged above 59 and above. They were asked to perform exercises with 2 different coaching styles, firm and encouraging. Before starting the exercises, each participant had a short conversation with the robot conducted in the Wizard of Oz style, where they were asked the LCES motivation questions and which coaching style they preferred, firm or encouraging. Half of the participants experienced their preferred coaching style in the first round, and the other half experienced it in the second round. The goal was to see whether people performed better when working with their preferred coaching style and whether they interacted more with that robot in that condition. From this study, we found that there was a huge mismatch between how participants answered the questions verbally and how they actually scored on the LCES. Most participants, when asked, answered that they liked to exercise. However, when they answered it on the LCES scale, this average was much lower. We also conducted a reflexive thematic analysis on the conversations between the robot and the participants and identified 3 distinct types of engagement. The most common one was answer-related engagement, where participants responded only when prompted, typically with a simple yes or no answer. The second most common was confusion-related engagement, in which participants asked the robot to repeat itself or express difficulty understanding or hearing it. The least common was social engagement, and only a few participants voluntarily shared information about their personal lives without being prompted. We had several key takeaways from our study 1, and the first was that there was a motivation mismatch between this LCES scale and how they answer the questions verbally. We also encountered limitations on the Wizard of Oz setup because the robot's responses were pre-scripted by the researcher. It couldn't adapt or rephrase in real time based on the questions asked by the participants. This sometimes made the interaction feel a little bit less natural and responsive. Another challenge was the auditory difficulty. Many of the participants had trouble hearing or understanding the robot, particularly those who were hard of hearing due to age. In some cases, participants didn't even realize that the robot had begun speaking, which disrupted the flow of turn taking. And finally, we observed that the conversations tended to be brief, and most participants did not initiate speech with the robot and responded only when prompted by the robot. Talking about study 2, in my current work, I'm exploring whether older adults prefer coaching with a social buddy rather than a traditional coach. This part of the project is grounded in social cognitive theory, which emphasizes that learning and motivation are deeply influenced by social interactions, observational learning, and the feeling of support. For older adults, especially those who may be experiencing social isolation, having an emotional connection and a sense of companionship can make a big difference in staying motivated. When someone feels like another person is expecting them to participate or is counting on them, it can also be a powerful motivator to stay consistent with the routine, which is the social accountability on the last part of the slide. Based off of the findings in study 1, we also made several changes to our approach. First, we transitioned from using the Cori robot to the commercially available Pepper robot that is commonly used in HRI studies. Additionally, we also introduced LLM-generated responses to support more natural real-time interactions, and this helped the robot provide timely answers and keep the conversation flowing, even when the participants' responses were brief. To address the auditory difficulties that some of the participants experienced, we also made use of the tablet on Pepper. By displaying the robot's speech visually, we aim to make the interaction more accessible by providing a multimodal method of delivering speech. This is the architecture of the large language model system. We use a transcription service that captures a participant's speech and through a microphone clipped onto them. The audio is transcribed and sent to GPT along with the prompt that helps generate a contextually relevant response. The response is then sent to the robot, which speaks it out loud and also displays it on the tablet for added clarity. All the spoken responses, both from the participant and the robot, are saved in the CSV file. This file is also sent to GPT to help maintain context across the conversation and keep everything on topic. And at the end of each session, the CSV is processed by another LLM to generate a short one-paragraph summary of what happened during the interaction. In week 1, all the participants received a standardized prompt to keep things consistent across initial sessions. From weeks 2 to 4, we used the previous week's summary as part of the prompt. This helped provide a contextual continuity and made the interaction feel more personalized and connected over time. This is an example of the AI-generated summary for one of the participants. As you can see, the person had high energy and they didn't feel pressured to exercise by anyone else. They also have a dog named Puppy, and that they had talked about what they liked to do with Puppy during the day in the first session. In the subsequent sessions, the AI system referenced the conversation about Puppy, and the participant noted that she noticed that the system had remembered about her dog. This was tested in a 4-week longitudinal pilot study where we recruited 3 participants over the age of 60 from the university's recruiting system. To test users' preferences in both personality style, we had the participants perform exercises with both the social buddy and the coach styles. Similar to study 1, the participants were asked the LCS motivation questions and took a survey after the initial interaction to evaluate the robot. Then they performed 2 sets of bicep curls and 2 sets of lateral raises for 2 rounds. Participants 1 and 3 began with the social robot, while participant 2 started with the exercise coach. In this Venn diagram, I want to highlight the differences between the social buddy and the exercise coach. The conversations during the social robot round were fully generated using the LLM system. The social buddy conversed about the casual topics such as pets or plans for the day and performed the exercises with the participants. The exercise round, on the other hand, used the adaptive coaching system, naturally changing from firm to encouraging styles. And while this system adjusts exercise feedback based on the participant's performance and fatigue levels, it does not converse with the participant about casual topics or perform the exercises with them. The feedback given is selected from a set of pre-scripted feedback that is selected based on what feedback needs to be given at that moment. We had several findings from this pilot study. First, some of the participants found that a chatty robot during exercise could be distracting, especially when they were trying to focus on form or keep up with the movements. A few also expressed discomfort sharing personal information with the robot. However, participants' view of the robot's awkwardness or perceived weirdness during the social session shifted over time, as seen in the graphs below. This highlights the longitudinal effects of interacting with the robot. In the post-study interviews, participants generally said they prefer the coach-style robot. However, at the same time, they also mentioned that they would actually like a mix of both styles of the coach and the social. When it came to the social interaction, participants said they liked the conversational topics that were unrelated to that they were related to the exercises that they were doing rather than the unrelated small talk. They also strongly preferred when the robot exercised with them, which is something that the social buddy did, rather than just giving feedback on the side like the exercise robot did. Looking ahead, we're planning a 4-week longitudinal study at an assisted living facility this upcoming August. In the next phase, we'll be incorporating facial and vocal emotion detection to better understand how participants are feeling in real time and how that affects their engagement. We're also interested in exploring a few other directions as well. One is developing an adaptive system that can switch between the coach and the social buddy. In the prior study, we used an adaptive system between the firm and encouraging style. Now we would like to do an adaptive system between the 2 distinct styles of exercise coach and social buddy. Another thing we're excited to explore is how the acceptance of social exercise robot might vary across cultures. What feels natural natural and motivating in one culture, for example, in Japan, might feel different in somewhere like the US. And finally, we plan to expand the range of exercise motions that the robot can demonstrate to support a variety of physical abilities and goals. Switching topics a little bit, as I previously mentioned, I am currently here in Japan for the summer doing an internship at the RIKEN Accessibility Lab. Here, I am currently working with the AI suitcase that is being developed at the lab to explore how social autonomy and shared control come into play when we have a robot autonomously guide those with blindness or low vision. I'm currently doing this research with Masaki Kuribayashi and Alan Wang, who are both researchers at the RIKEN. The AI suitcase began as an idea in 2017 from Dr. Chieko Asakawa, who is the RIKEN's chief executive director. Dr. Asakawa, who is blind, came up with the idea when she wondered if her suitcase that she was currently using while traveling could help guide her. Since then, the AI suitcase has gone through multiple iterations and advancements. This is the current model that I am working with. The suitcase is equipped with a range of sensors, including 2 LiDARs, one on the top and one on the bottom, 3 RGBD cameras, a haptic-enabled handle with buttons for user interaction, and a smartphone interface. For my project, I have also added an external speaker to the system. The robot autonomously maps a route and guides users to their destination. Currently, the robot is being deployed at the RIKEN as well as the World Expo in Osaka. My project looks at the question, who takes control during navigation? When we design an autonomous robot, we often assume that the robot will do all the work. But in real-world settings, that's not always possible. For example, at the World Expo, where a robot's being tested, we've run into situations where it cannot move no matter what. These are because of crowds that are static or dynamic, objects, or lines that are being formed to line up at expo locations. When the robot gets stuck, there's a few ways we could handle it. The robot could speak out loud to the crowd and ask people to move, so the user doesn't have to, or the user can be the one to speak up and ask others to move. In our study with blind and low vision participants at the RIKEN, we're looking at how people respond in these kind of situations. We're interested in when they choose to take action themselves instead of when they make the robot do it. We're also looking at what kind of information they need to make that choice and how these preferences change over the time as they use the robot over the course of a 3-week period. We're currently in the middle of a 3-week user study. This would be week 2 with blind low vision participants, and I am very excited to see the results. Thank you for listening, and I'm happy to answer any questions.
So thank you very much, Rayna. And so at first, is there any questions from the floor? And then we may accept questions from the online participants. 質問お願いします。
先ほどそのモチベーションを確認するときに質問でって QA でって形でやったんですけど、結構実際の高齢者の方って嘘っていうわけではないんですけれども、ご本人の辞任と実際の身体状況が変わってモチベーション心身がちょっと差異があることがあるのかなと思っていて、時にその客観的な指標とかは入れた方がいいのかなとも思ったんですけど、どうなんでしょうか。
確かにそのモチベーション聞いてるときに、どうですかって聞いたときには、やっぱり大丈夫ですっていう人が多いんですね。はい。で、その時に、まあ、1個のやり方は、これを3週間続けて、3週間同じ質問、同じことを答えるかっていうことを見て、もう1個はその、モチベーションを言葉で聞いた後に、さっきもサーベイも出してるので、そのサーベイで私たちに喋らずに、一人でコンピューターで言ってる時にどうなるかっていうことを見てるんですね。だから数字でそのサーベイの方を見て、あと言葉でどう言ってるかって言ってコンペアして、それで一緒になるかという感じで見てるんですけど、質問答え。
The question is that older adults may hesitate to say that they are not motivated when they asked whether they are motivated or not. But then the question, is there any subjective and objective evaluation, and are they the same or different? And then her answer is that she does survey using the kind of both are self-reported, but
yes, I can, yeah.
Yeah.
So the answer to my question was that when we do the survey themselves, we ask them verbally and have them respond out loud through to the robot, which they know that there are people in front of them, so they might not answer truthfully. But the survey that they're answering on the tablet during the actual studies, that's self-reported by themselves. So we are hoping that they are able to answer those a little bit more truthfully than they might answer to a person. Another thing is that we're looking at it through a longitudinal study this time around. So we're also looking at if their answers stay consistent throughout the entire time. Our hope is that, after they come in several times and they get used to the robot and they see them as more of a companion or more as something that can be trusted, that they will be a little bit more truthful in their answers and willing to open up more.
Thank you very much for asking both in English and Japanese.
No problem.
Answer to the questions. And how about?
Thank you so much for the presentation. From your experience, are the populations across the globe ready to welcome robots in their everyday life? It's a very simple question, but I think across the globe we have like different populations.
Right.
Japan,
Yes.
US, Europe.
Right.
How do you see it from your experience?
I think no problem. Thank you for the question. I think that from what I have observed, at least from my studies in the US, that these people are not very comfortable with the robot. A lot of the feedback we got was, it feels weird to be talking to a robot. I don't want to talk about my family or my personal lives to a robot. However, working at the MIRAICON, the museum is full of robots and displays that, show human robot interaction. And my wondering is that, as people are exposed to that kind of from a younger age, I see a lot of school kids coming in as field trips to the MIRAICON. And I wonder, because of that culturally, places like Japan might be a little bit more welcoming of a in-home robot. There's also perceptions of, how culturally in movies and things like that, robots are displayed very differently. In Japan, for example, we have Doraemon, right, which is a helpful household robot, and that show has been going on for years. Versus, for example, in the US, there might be movies that show robots as more of destroying objects. And so based on that too, our view of how we see robots might change. To answer your question, so I think that across the world, I think there are different acceptances of robots, and depending on where we are, yes, it might be hard to make people use such a robot in their homes. I hope that answered.
Thank you very much. Is there any questions from the floor? Yeah. So one of the participants, Dr. Kumagai, has some similar study experience, and also about turn taking as well.
質問は、you prepare two kind of characters, I mean, exercise buddy or なんだっけ、もう一個、
Coach.
coaches. And what if maybe you will start your next experiment, but I wonder what if both of them are not, I mean, adapted to the participants. I mean, なんかどっちも
どっちも好きじゃないという感じ。
だからどうするか。
はい。So her question is, what happens if the participants, both the types of robots, social and exercise, what if participants like neither of them? That's the gist of your question. Yeah, so ちょっと日本語でしゃべはい。好きじゃない場合は、この実験の中で何が好きで何が嫌いかっていうことを、探ってから、見つけるという感じで、次の3つ目のタイプを作るという感じの方法に行きます。
ありがとうございます。
My response to that answer or that question was, depending on how we see the results in this current study, if the participants, people like neither the exercise coach or the exercise buddy, then we will use the results from this current study and make a third type of character, hopefully to make it so that we kind of at the end converge into a type that people like. One of the things is that in study 1, we only looked at the exercise coach system, and I from there took in that maybe people just don't want a coach because maybe, a coach isn't motivating enough to show up. So I said, okay, what if we take something that is more like a friend? And that kind of came from the observation that when we ran the first study, the group of people who came into the study, they were all kind of friends. They were all part of the same exercise group. They told each other that this is a pretty good study, that they like to exercise. From there, so there's a slightly bias there. But what I observed from there is that maybe there's more of a social aspect. These participants said they all kind of ate lunch together too and all of that. So they are a social group, and that social group's theme is exercise. So I said, what if we leverage that social interaction and make a social buddy system instead? So using study 1, I transition to study 2, and then hopefully from study 2, I will transition into converge into a type of robot that people like.
Thank you. I have a small question on, so in study 2, you compare 2 cases or only exercise body?
2 cases. I compared, so first, in the first round, people either had the social robot or the exercise buddy. And so going back to this Venn diagram here, these are the 2 types of robots people encountered. And so in round 1, participants 1 and 3 encountered the social buddy. And so they chit-chatted with the robot while exercising. And then in round 2, they interacted with the social coach, where they were only given feedback on how they were exercising.
So the order was all the same for all pilot study participants?
For 1 and 3, it was, so we try to balance it so that half of the participants saw the first one in the first round, and then the other half, we only had 3 this time. So it turned into a 2-1 situation. But participant 2 saw the exercise coach first.
So, but all the participants experienced both cases?
Yes, but they experienced both, yes. And we had them kind of compare the 2, both all 4 times that they came in. So after the second round, we asked them, which did you like better? What did you like about the first type? What did you like about the second type? What do you wish the first type had that the second type had? First type had that the second type had, like that kind of thing.
So were there any order difference for them? Not so much?
So the unfortunate thing is that Pittsburgh had a massive power outage during my study, and participant 2 could not come in all 4 weeks. So I don't have a quantitative data for that person, but from our post-study interviews, the participant 2 said that they also didn't like talking to the social robot. So analysis-wise, all 3 of them did not like talking to the robot, but participant 2 said over the course of the 3 weeks that she came in, she found that, towards the end, she thought it wasn't like that big of a deal, and it's okay to talk to the robot. So her acceptance of the robot kind of went up as time went on, which is the same as participant 1 and 3. So all 3 of them, long story short, basically accepted the robot more over the course of the 4 weeks.
And they used at home?
They came into CMU this time.
Came to CMU.
Yeah, the August study will be at an assisted living facility, and we have about 8 participants recruited for that.
So, and they come to the CMU, and then so they usually do exercise with other groups, or?
No, most of these participants either don't exercise, or if they do, they walk their dog. Participant 2 specifically is not someone who likes to exercise, but started bringing in their own weight. They bought their own weights from Amazon and started bringing in their weights so that they could work out with a robot.
I see. And the study 1 was more of a kind of exercise-friendly people.
Yes. Yeah. Study 1 was more with an exercise-friendly people. We went to an actual facility and recruited them. And from the recruitment, the people who were more likely to come in were the people who are more exercise-oriented. Yes.
And then so for the study 2, you recruited more exercise not friendly people.
We just sent out a recruitment list within the CMU's recruitment website. That website itself doesn't have that many people who fit the criteria of over the age of 60, which is why we only got 3 people.
So no, not necessarily. You didn't mention whether they like it or not. Is not the kind of condition
for them this time. For study 2, we also did ask if they like to exercise or not, and all 3 of them, 2 of them said they like to exercise, and 1 of them said they don't like to exercise. But that was not a condition that we asked before recruiting them.
I see. As a result.
Yes, as a result, yes.
Okay. Any questions? Naoko-san, so she's a occupational physical therapist, and so she always support exercise as her profession. So how do you think about? 日本語で。はい。
大丈夫です。はい。
私実際患者さん見ていて、私がこう1対1でこう人同士で1対1でやっていても、実際運動のモチベーションとか、要は私の場合リハビリですけど、リハビリのモチベーションを維持したり上げていくってとってもすごい難しいので、それをあれですよね、こうロボットを介して何かできないかっていうお話だったかと思うんですけど、実際ちょっと話がちょっとわからない分、私さっきなんかフィードバックもするみたいな
これ、すみません、今スライド、これでしたね。これですか？
そうです、そうです。これって具体的にどういうフィードバック、ロボットを介して利用者さんというか参加者にフィードバックをしてるってことですよね。
ロボットはカメラを使って、
はいはい。
肩から腕の、アングルを見てて、それでそれを手が上に上がってるかと手が上に下に下がってるとか、そういうことを見てて、もしもパーセンテージ的に100%、80% ぐらい上に上がってなかったら、だんだんちゃんとしようねっていう感じで。
なるほど、なるほど。はいはい。で、なんか、それをじゃあ、さっきよりどんくらい良くなったねとか、前よりはこんくらい上がるようになったよみたいなことを
それはまだやってないです。
なるほど、なるほど。ありがとうございます。なんかそう、自分もやってて、こうモチベーション上げるときって、こう、患者さんに効果を分かってもらうっていうのが一番手っ取り早いと、変な話手っ取り早くて。
多分そう。それがもう一個、次のスタディでやりたいことは、どうその人が何%良くなったかっていうことを見たくて、この最初に作ったスタディ1の時は1日しか来てくれないので、それをやる理由がなかったんですけど、次の3週間、4週間来てもらうと、やっぱり、なんか、良くなりましたねとか、先週は10回できた、10回できましたねとか言った方がいいと思います。
ですよね。なんか、そういうのがやっぱり一番、こう、患者さんとしては刺さる。
はい、そうです。そうだと思います。
なるほど。ありがとうございます。
Please briefly summarize in English, please.
So she asked if in our study 1, when we gave feedback, if we also gave feedback on how, or not just study 1, how well they did compared to the previous session, and how that usually helps older adults understand that they're improving. And yes, we just discussed how, yes, in the next study 2 or study 3, when we're doing a lot more longitudinal work, how I would like the robot to be able to also not only summarize what they talked about, but how well they did in their previous session, and see if there's to see if we can motivate them by reminding them what they did last time.
Thank you very much. Yeah, because online participants, both English
Yes,
speakers and Japanese speaking people are there. And so I will ask, so Shibata sensei, the organizer of this seminar is now raising hands. And so Professor Shibata, please ask questions.
Okay, thank you very much. Can you hear me?
Yes, thank you. Yep.
Okay, great. Thank you very much. So it was very nice. It's very nice to see you. And so I remember that Hata sensei and I were in the same workshop and in the past, when we were just very young researchers era. Yeah, so I'm very happy to. And I have been working in this field, a similar field, for caregiving and care science also. So I was totally impressed by your presentation. Thank you very much.
Yeah.
I studied a lot. So would you please go back to the page 33? Similar questions were already given, but I still would like to discuss a little bit.
Here, is this one the correct one?
Yeah. So in your study, of course, so you have conducted some systematic way of doing, so experiments. So round 1, round 2, and you assign social body or exercise coach. But actually, we are interested in the recurrence, so what is happening in the recurrence way in the interaction, human-robot interaction, right? So I usually feel so always the ground truth is in the middle. So I think, so we sometimes need to use a social body system, and sometimes, depending on the status of the patient or participant, sometimes better to switch to exercise coach. So in a time series manner. So what do you think about my opinion? And is there any way to, so I think you said you didn't acquire some quantitative information, regarding the participant status, but I'm very much interested in measuring, their status, participant status, quantitatively. And I would like to conduct long-lasting research where sometimes we need to switch the Asian system to social body type, and sometimes exercise coach type or something like that. What do you think?
Yes, I totally agree. So the preface of this study, study 2, was to explore if the social buddy system was something that people wanted. In my previous lit review and prior work search, I didn't see that many two-way social buddies, robotic systems that interacted with the person. A lot of that was exercise coach and the robot giving feedback to the person. It could be social, but it was always exercise related. And so I agree that what you just said about how that depending on, I'm assuming what you said was depending on the day, some people might prefer the social buddy and some people might prefer the exercise coach. Is that correct?
Right.
Yeah.
Okay.
So
Yeah.
So that's partially why I did the longitudinal study, was to see if their preferences changed over time. So over the 4 weeks, I did ask them if they prefer for that day, if they prefer the social buddy or the exercise coach. All 3 of them said they preferred the exercise coach. Like if I were to ask them to give me a pick one or the other, they all said exercise coach. However, they said, I didn't like some of the things that the exercise coach did, for example, give nonverbal feedback, because it was hard for me to look at the movements that the exercise coach was doing for nonverbal feedback. I would rather see it perform exercise with me, which is something the social buddy did. They also mentioned that when they are fatigued, they would rather have the buddy be quiet and be more like the exercise coach. But at the beginning, or when they want to kind of just start the exercises, they don't mind having a conversation with the robot. They prefer that the conversation be more exercise centered rather than, asking them about their day. So we did see like a shift of back and forth of, I want this type, but also I want the social buddy, I want the exercise coach sometimes. And so longitudinally, what they converged onto was they like the exercise coach with some changes.
Yeah, okay, thank you very much. So thank you very much for the detailed explanation. I understand you did, so what I wanted to do, actually. Thank you very much. And so I have one more question. So this may be a bit of tangent, but have you observed any moments when dialogue with the robot encouraged all the adults to act on their own, such as getting up, walking, or exercising, or something like that?
Not quite. The way we conducted our experiments was they came in on their own and they sat down and they did the exercises and then they left. They did come back for 4 weeks. And that we gave them the option to drop out at any point. But they did come back for 4 weeks. And one of the participants did bring in her own. So we had 1 pound weights and 3 pound weights. And she found that those weights were a little bit too much for her. So she actually bought her own weights and came in with her weights every time. So in that sense, she found that having the robot coming in to do the study and exercising with the robot actually motivated her to take this extra step of making sure that she can get the most out of these sessions.
Okay, thank you very much. So I really would like to give one final question. Sorry. Yeah. So actually, in my laboratory, we have been doing some, so motor related experiments. So for many years with Parkinson's disease patients, but unfortunately, they changed their behaviors a lot in our laboratory. Quite different. For example, they had, we are sure that they had a significant freezing of gait at home. But in our laboratory, they walked very nicely and they looked very comfortable, enjoyable. So they changed totally the behavior. And you conducted also the experiments in your laboratory. And what do you think? Did you see any such change in their behavior, or in the future also you might want to conduct some experiments at their home?
Yes.
Yeah.
So the people, like you said, who came into our lab, they did come on their own, and they came because they wanted to. The people who are so in August we're doing a study at an assisted living facility, and these residents reside there full time. And so we are doing the study there for longitudinally. And I think it would be interesting to see what their opinions are of the robot, for such a robot that could live in their own home, live in such facilities, instead of having to come to a facility like CMU or any of the other physical therapy facilities around them. With that being said, the people who are being recruited for this, it is a voluntarily thing, which means that they are coming in because they want to. And so that may bias them a little bit more.
Right, and also they can meet you, Rayna. So they must be very happy.
Thank you.
Yeah.
Yes. Yeah. So another thing is, there's the novelty effect for robots is huge within this age group. The first time they encounter a robot, they think it's really cool and it's this new thing. And so we're hoping by doing this study for 4 weeks that we can eliminate the majority of the novelty effect, and that we can get actual opinions about how they feel about the robot by week 4.
Okay, thank you very much. Great, thank you very much, and good luck on your future work.
Thank you.
Yeah, really, so I'm looking forward to, so listening to again, your talk in the near future. Thank you very much.
Thank you.
Thank you very much. And is there any questions from the online? And I found the name. Oh, disappeared. I wanted to. So but I found Miyake-san. Do you have any questions?
Well, I was just planning to ask what Shibata-sensei asked. So thank you very much.
Yeah. And I have another small question. You do exercise for how long? For one session?
For the participants,
Yeah.
so they do 40 seconds of bicep curls twice, and then they do 40 seconds of lateral raises twice in one round, and they do that round twice.
In total, how long? 40?
40 times 8,
2, 4.
320 seconds.
300?
And 20 seconds, which would be
seconds.
Yes, yeah. We measured them in seconds. They have 40 seconds on, 40 seconds off. In total, the entire exercise session with breaks is approximately 10-ish minutes.
10 minutes? Or so you mentioned seconds?
Yes,
And
yes.
then
Sorry, so they will
into-
exercise for 40 seconds doing bicep curls, and then they have a 40-second break. And then they'll do another set of 40 seconds of bicep curls, and then they'll have another break. And then they will do lateral raises for 40 seconds, break again, and then lateral raises again. And they do that whole thing once, and then they do it again for the second round.
So, and then during that, so the robot shows the motion?
Yes, the social buddy. So the social buddy version does the exercise with them. Let's see if I can flip on to this page. This one, in the picture to my left, the robot is in mid motion to do the bicep curls. So the participant is doing bicep curls, and the robot's also doing it with them. When it's conversing, it's standing still. And then in the exercise coach system, it's giving nonverbal feedback. So for example, if someone's doing super well, let me be the robot, and they'll just go bonsai kind of style, right? Right. So they will kind of give this big movement of being like, you're doing really well. And that's the movement that they'll do. Because participants didn't quite understand that movement, they just preferred if the robot just did the bicep curls with them.
So the robot shows the ideal motion.
Yes.
And so the degrees of freedom of robot is enough for this
Yes.
specific.
It's enough for them to understand what the exercise is. And then if they're not doing it well enough, the robot will give feedback, being like, make sure you're raising your arms higher, or your left shoulder, make sure your left shoulder is going higher, your right shoulder is going higher. It'll also be like, keep up the good work, you're keeping a good pace, things like that.
Yeah, sometimes the robot degrees of freedom is not enough for
Yes,
human
this
degrees
one,
of freedom.
in my personal opinion, I think is enough. I basically programmed it to go to a certain angle. It probably starts, around its bottom and just goes up to here. The lateral raises are down here and goes up to here. So it's pretty good. It's partially the reason why we wanted to use the Pepper robot is it has elbows. The Pepper robot has elbows, while the Corey robot actually
doesn't have elbows.
Yeah. So Corey doesn't have elbows, so it's very hard to show the motions using that robot.
So having a physical body is enough meaning for Pepper.
Yes.
In this.
Yes. Embodiment itself is definitely more meaningful. Going back to your first question, some of the reasons why we have a robot instead is that subjectively people tend to act differently when there's a robot in front of them instead of a computer screen. People also act differently when there's just a camera in front of them. So the feeling of being watched or being in the presence of something else changes how people react to themselves.
Is there any comparative study of display and robots in other studies or existing studies, or not so much? Field exercise.
Sorry, can you repeat the question again?
So the showing the motion by just on the screen, and so showing by the robot, and is there any?
I'm actually not entirely sure if there's a comparative study between showing it on the screen versus showing it on the robot. There's just a bunch of studies that show the importance of embodiment, but I wouldn't be shocked if there actually is.
You have not yet, and also there doesn't exist, or
I'm not entirely sure on that part. I don't know if it exists, or I need to do better research on that.
Yeah, there might exist, but I don't know. So
right, yeah. That's something that I need to look into, is if that's actually something that a computer screen showing the exercises versus a robot, if there is a comparative study on that.
I see, because we did a comparative study of speakers and the moderating robot.
Right. Yes,
Yeah.
I remember.
So maybe so it might be better, but whether it's already shown or not shown is my interest.
The objective is to just place an object in front of the person, a humanoid-like embodied object. That itself can change the behavior regardless of if they're exercising or not. But I think it would be interesting to see if there's a comparative study between,
not necessarily exercise, but if there's an exercise, that'd be fine, because
that would yes.
Maybe it depends on this what kinds of exercise.
Yes, yeah, exactly.
So if the exercise is too difficult for the robot, and then only the means is to show that.
It's to show, yes. In the first study, we only showed the exercise motions through a tablet. We had an iPad and we just showed them how the exercises were, because Corey couldn't, and
not enough.
Yes. And if they still didn't understand, we would do them. We would do the exercises to show them. But with Pepper, they seem to understand the exercise, and they would notice that they're doing it incorrectly, so they would correct themselves if they started doing off wrong.
I see. Thank you very much. Almost it's about time, so thank you very much.
Thank you.
Yeah, so from the floor, thank you very much for your active participations. And so this is the email on the screen, so you
please
can
feel
ask
free
questions
to reach out to me.
Yeah, thank you very much.
Thank you.
Thank you very much.